Hello everyone, and welcome back to another GIS lecture video. And in this GIS lecture video, I want to continue our discussion on symbolization by diving into this idea of levels of measurement. So the way that we approach levels of measurement is what we are describing, if we give ourselves a little bit of space here, is we are describing the types of variables that are found within a data set. So again, levels of measurement or categories of data what we're talking about here are the attributes. So we are not talking about spatial data. So we're not talking about points, lines, and polygons, vector or raster. What we're talking about are the values in the attribute table. Use of attributes for vector data or cell values for raster data, right? Have properties that fall into one of four categories. Right, so we're talking about the values of attributes. So this could be, for example, say you have census tracts, and those census tracts have, right, so let's use an example, census tracts. Right, so we have census tract polygons, the census tract attribute table, right, has the following variables. It has a variable for the ID number. It has the variable for crime ranking. It has the variable for the average income. And then finally, they've decided to include, for some reason, the weather variable average temperature. Right? And so we have census tracts where we have the ID number, the crime ranking, the income, and the temperature. And in the back of our minds, we're thinking that maybe ranking crime, income, and temperature might be related to each other. Maybe we're thinking that areas that are incredibly cold might have less crime because criminals are less likely to go outside. Or maybe we're thinking there's a relation between income and temperature. Whatever the thought being, we have these four variables in the attribute table for some census tracts. So what I want to do is I want to talk about the properties of these four variables as they relate to the four categories of levels of measurement that we're going to talk about. So we're going to be coming back to this idea of the census tract and these four variables here. So let's go ahead and talk about the first level of measurement, which is nominal. So for nominal data, what that means is that nominal data are variables that are non-numeric and have no order or ranking. Right? Variables that are non-numeric and have no implied order or ranking. So this would be variables that are basically names or identifiers, right? So things like names, right? Identifiers, colors, right? Things where they're non-numeric, right? We can't do math on them, right? We can't say that a census tract ID number, right, 01002 is any better than the census tract 03416, right? These, you cannot say one is better than the other, right? They're not ranked. Even though they're numbers, right? It's an ID number, meaning you cannot add or subtract them. It doesn't make sense, right? So this here, this ID number, right? This is an example of nominal data, right? It's nominal data because ID numbers, things like names, so like my name is John, right? My name is no better or worse than maybe Sally or Tim, right? We can't add, subtract, multiply, or divide anything, right? John times Sally makes absolutely no sense. So there's no numeric association here, and there's no ranking or order associated here, right? These, you cannot say that one of these implies being better than the other or worse than the other or any sort of ranking there. So nominal data is pretty straightforward. Next is going to be ordinal data. So with ordinal data, right, it's similar to nominal in that it's non-numeric. So these are variables, right, that are non-numeric. Right, so again, even if they are represented by numbers, they don't mean numbers, so you cannot add, subtract, multiply, or divide, right? But here's the difference, right? They have, or I should say that, have order or ranking, right? And I'm gonna underline the word have here. They have order or ranking. So let's go back to this idea of the census tract. So we have this attribute here called crime ranking. And in the crime ranking, right, we may have something like high, not hinge, right? We could have high, medium, low, etc., right? When you look at this, right, intuitively, you say, oh, high would have more crime than a low crime ranking tract, right? So we have this idea that, oh, one of these things is more important, more significant, right? Generally speaking, bigger in some whatever context that may mean, right? But we can imply that one of these has something different from the other. That is what we mean when we say that it has an order or a ranking, right? Another example of an ordinal variable would be the medalist positions at the Olympics, right? Bronze, silver, and gold, right? We know that gold is better than bronze and silver, but we can't say it's twice as good or that bronze is half as good as silver, right? We can't do any math there. They're non-numeric, right? You could say first, second, and third, right? Even though we're representing them with a number, right? They're still non-numeric in the sense that we can't do math on them. So when we have this idea of order or ranking, but it's non-numeric, we call this ordinal data. So this right here, this is an example of ordinal data. Okay, so let's talk about the last two types of data. Let's talk about interval versus ratio. All right, interval versus ratio. So interval data and ratio data are both numeric. The difference is how they treat the 0 position in that data set. So for interval data, right, this is a variable that is numeric, right? So as opposed to the two non-numeric that we had up here, the numeric variable, so this is traditionally numbers, right? And the numbers mean what we would traditionally think of as numbers. So we can do things like add and subtract. Now the difference here with interval is it's numeric data, but the 0 is what's called arbitrary. I'm going to underline arbitrary here. I'm going to underline 0 is arbitrary. So conversely, right, ratio data, right, is a variable that is numeric. So again, right, numbers, but the 0 is absolute. Or put another way, the 0 is non-arbitrary. So interval, arbitrary 0, ratio, absolute 0. Now, you might be thinking, okay, what is the difference, right? What is the difference between absolute and arbitrary? Right, and basically the question is, right, does 0 mean 0? And what do I mean when I say does 0 mean 0? What I mean is, does the number 0 truly represent nothing? Right? Does the number 0 truly represent nothing? If it does, then it is an absolute 0. If the 0 does not truly represent nothing, then it's arbitrary. Right? So a good example of an absolute 0 or a ratio variable would be the amount of money that you have in your pocket. Right? So if you open up your wallet or your purse and you look at the money that you have, right? If you have 0 money, that truly means that you have no money. Right? So that's a ratio. That's an example of ratio data. So an example of ratio data could be money. Right? Another example of ratio data could be the height of a person. Right? If we measure their height from the ground, right? A value of 0 means that they have no height, right? So 0 truly does mean 0. So let's talk about variables that are arbitrary. If the value does not truly mean nothing. So some good examples of this are temperature. Right? If we think about temperature measured in degrees Celsius, for example, right? Water freezes at 0 degrees Celsius. But does that mean that there's no heat left or no temperature left? Well, of course not, right? You can go into the negatives, right? Temperature can go below 0. And in that case, right, 0 doesn't mean that there's nothing left, right? It just is a placeholder. Right? So a good example of interval data, right, is temperature. Right. Another example, think about elevation measured above mean sea level, right? Where mean sea level is the average sea level measured based on the ellipsoid and the geoid and the vertical datum. What does zero elevation mean? Well, it means that you're at sea level. Can you go below that? Absolutely. So zero does not mean zero, does not mean nothing, right? So as a general rule of thumb, this is not always the case, but as a general rule of thumb, the question I tend to ask when I'm thinking about ratio data is, do negative numbers make sense? If the answer is yes, then it's likely to be interval. If the answer is no, then likely to be ratio. And again, I'm putting the word likely here because you really have to think through, more than anything, whether or not the zero represents nothing. But negative numbers are a good indication that whether or not that is true. Because if negative numbers make sense, then that likely means that you can go below zero, which means the zero doesn't really mean nothing. Because if you can go below zero, then zero doesn't mean that you don't have more left that you can lose. So why does this matter? The reason this matters is because with interval data, right, we can add, subtract, rank, and order. Right, so if we take temperature, for example, right, we can say that one state was 30 degrees warmer than another state. We can certainly say that this state was hotter or colder than another state. But what we can't do is multiply and divide. Now, I want to be clear here. When I say we can't multiply and divide, I do not mean that a calculator will throw an error. And this is a really big issue in cartography, is that computers don't know, right? They're not smart enough to know whether your data is interval or ratio. It just sees numbers. So the built-in software for calculations, so things like the field calculator, for example, in ArcGIS Pro, right? It's not going to throw an error if you try to multiply or divide interval data. It'll let you do it, but the end result, the map, is going to be misleading and not valid. So what do I mean when I say that we can't multiply and divide, right? So say, for example, Arizona is 60 degrees Fahrenheit. Meanwhile, Michigan, right, is 30 degrees Fahrenheit, right? So this is interval data, right? We can say things like, right, Arizona is warmer, right? That is a ranking or an order. That is a true statement, right? We can say things like Michigan is 30 degrees colder, right? That is adding or subtracting, right? We cannot say Arizona is twice as warm, right? So this would be, right, 60 over 30 equals 2, right? We cannot do this. This is not a valid comparison. And the reason why is because the 0 in interval data does not mean nothing, right? That is why this comparison is invalid, right? We cannot make these ratio comparisons. That's why ratio data is called ratio data. And that's why interval data is called interval data, because we can take intervals, we can add and subtract, but we cannot take ratios. Conversely, just to kind of put a bow on this and wrap this up, right, with ratio data, right, we can do all the stuff that we could do with interval data, right? So we can add, we can subtract, right? We can rank, we can order, right? But what we can also do is we can also take ratios, which is multiplication and division. And I'm going to clarify, when I say multiply, divide, I mean take ratios. Because you certainly could multiply both of these by some number like 2, right? That's okay. But you cannot compare them using division to make ratios. So, to wrap this up, let's go back up here to our example of the census tracts and talk about average income versus average temperature. Now, I've kind of already given away the game here a little bit, but because we've used these two specific variables as examples. But for income, right, we may have one that has an average income of 53,000, right? Maybe one has an average income of 25,000, and maybe one has an average income of, say, 90,000. Right? But if we have 0, that truly does mean that the average income is nothing, right? So average income in this case is an example of, right, this is an example of ratio data. And then finally, for temperature, right, maybe the average temperature for this one was 63 degrees. Maybe this one was 57 degrees Fahrenheit. Maybe this one was, say this one was a little bit colder at 45 degrees Fahrenheit. Right, again, as we already talked about before, right, when we talk about temperature, right, degrees Fahrenheit, 0 does not mean 0. So this is always going to be interval data. Okay, so hopefully this made sense. Just to recap, nominal and ordinal are non-numeric. Nominal has no implied order or ranking at all, so it's things like names, identifiers, and colors. Ordinal data is non-numeric, but it has a ranking, so we can typically order the data by some rank. The numeric data options we have are interval and ratio. Interval being defined as having an arbitrary 0, meaning that the 0 does not truly mean nothing. And ratio being an absolute 0, meaning that it truly does mean nothing. And a good indicator here is thinking about the idea of negative numbers and whether or not they make sense. The key difference being with interval data, we cannot take ratios between two observations, whereas with ratio data, we can, meaning with ratio data, we can say things like, this is twice as large, versus intervals, we can only say, this is this many more. Hopefully that all makes sense. And as always, if you have any questions, please reach out. Thank you.